Hello and welcome back to Compiler Programming. Today I thought it's time for us to start working on the error messages, because if I'm to use this compiler for anything non-toy, then it would be nice to see where the error happened and not just have it crash with an assertion as it does right now. So let's start working on that. I guess I will need to get some tests in. Or maybe we can use the source test file for that. I'm not sure which one is better. I guess doesn't really matter. So let's try this out. Okay, we have tokenizer result and we check for tokenization, and after that we should be checking for parsing the input. And I guess I will need to prepare some more stuff, so maybe I should move it here. Yeah, let's just write it here. Doesn't really matter where the tests are. I will need to reorganize them at some point anyway. So here it is. Should report a user understandable error. Let's start with the error when we could not look up a type. When encountering unknown type. Okay, what that would look like. Let me copy paste maybe some test I can work on, or maybe I will grab this one and move it closer to the tests that actually use source files. Okay, that looks about right. Okay, here we have the source files. So now we can copy this one, and I guess I have this test program in line source, which is a macro I added to be able to easily add more tests. And I wonder if that's a good thing to use here. I guess it doesn't really hurt. Okay, let's, or that's it. It's a bit of fun. I guess not. I guess we want to do it like this, and the token match module is the something that will give us errors back. Okay, so we have main, and doesn't really matter. We can say, for example, S33. So let's say I mistyped and we have X that is here and it returns nothing. So that's okay. Tokenizer should be successful. And now if we try to run tests, test will just assert, and that's something we want to fix, I guess. Yeah. So the reason they do not assert right now is because I am actually not forcing the value. So currently, unless the function is used, it's not actually compiled. So that causes this issue where the program is successful, just doesn't really we didn't actually evaluate this function here. Okay, lookup force, and I want to provide slice literal main, I guess, and like this and like this. Okay, let's try it again. Okay, now we do have an assertion failure, and this is where we can actually do something about it. First of all, I think I want to have something like parse, like program parse, or sourced parse function that will do the tokenization and that will do the main parsing. So basically execute this call, and maybe we will actually say what is the function that we are trying to do here. I'm not sure what is the best way to go about it, because that feature that I told you, or the setup that we have where the functions are not actually evaluated unless they're forced, means that we can have errors at this stage, but we can also have errors at this stage where we try to look up this value in the program to kind of kick off the actual compilation. And yeah, this is interesting. Maybe I will change my mind and force all the function to be checked. That's, I don't know what is the right way to go about it. But let's start with something. So we'll go here, we'll go to the end, and we'll say something like program. I guess we have this program import file that is doing something similar. Maybe we will say we'll program parse, and it will accept a program, and it will accept a path, or not the path, it will accept actual source code here already. So source, and then we are just taking this stuff out, putting it here, and saying return program parse program source. So this is just a wrapper that will load the file, but this is going to be the main loop that actually does stuff. Tokenize, file path. Okay, so we do have to pass it down. That's not a problem. Program file path stores. Okay, and here we say return true. Okay, that does not actually do anything for us because we are not using it, but we can use it now. What I can do is I can also make that function receive a literal for the entry point, and it will do this lookup call, and it will now return a value. We'll also do program end, which means that we should be able to actually force it in one step and return a nice error list back eventually. Okay, that's not the best API because we have 3 arguments that are slices, but what can you do? Slice entry point name. Okay, and this thing will just do lookup force, right? Result, and now it will return value star. So here for now we'll just do this to maintain the same interface as we had before. Okay, value star result. Okay, we get the program. We try to look up this entry point name, and we pass 0 here, which I think is like the function builder or something. Okay, and for now, let's just say return. No, actually, I don't need to split this up because I also need to say program end. Program end of program. Although program end is a JIT part, I don't know. This all feels a bit awkward. Yeah, I'm not doing that. So we are undoing these changes and keeping it like this. And here, like so. Okay, let's get back here and figure out what we want to do. So we will have program parse, and let's replace that. We say check program parse of program underscore test file name and source. I think this is the right order. Yep. Okay. So we check that. That will take care of these three things for us. And final one is lookup. If only I can spell program, that would be good. Okay. Yep, we still get the assertion. And now the question is, where do we put the errors? So there are a couple of options. We can return a result object, same as we do in tokenization here. So we would receive something like that, tokenize the result, and we would get the parser result, and it sort of has the same structure. Or we could attach it on the program itself, and since we are already passing it all around, then it's gonna be fine, I guess, to just put it there. Not sure what we did the right approach there. Well, let's go with more explicit version and to create a custom struct. So type def struct to parse result. Yep, and then we need an enum. Type def enum parse result type. We have success, and then we have error, and then we obviously need to have it here, so type, and we might have array. I already forgot, so we have tokenizer error, and I would probably rename this to like a both tokenizer and these parse errors should probably be just parse errors, because for the user it doesn't really matter where the error happened. So let's change that around then. We have this, and we have this, and we have this, and then we just replace it everywhere and see how it goes. Okay, I also need to replace it here, and this is fine. Good. Let's continue with the setup then. So we have this enum, and we are ready to return it. Okay, parse error, errors. And now if tokenization fails, we don't print errors, we just return them further. So this is sort of a standard approach where you get there, you pass it up. Since C doesn't really have exceptions or any other good way to handle errors, this is what I'm going to be using. Okay, result is not success, then we return parse result. Let's say type is parse result error, and errors are result errors. I think I should rename these to tokenizer result to be more explicit. Okay. So this is good. And now we do need to actually start producing those errors and pipe all of these around. Okay. Tokenizer result. And here I'll just say return parse result, success, and we don't care about the error field. It's just going to be uninitialized, but that's fine. Okay, now onwards. We do want to pass around the array for the errors. So this is something that we need to create. Array parse error is, you know what? I think I will attach it to the program after all, because it's fine. Program init. Yeah, that would be okay. Program blah, blah, here, and we just say array parse error errors. Okay, and maybe even parse error is not a good name because we'll have like mismatches of types and stuff like this, but whatever. Doesn't matter right now. I do need to move these definitions from here to the header file, I guess. So token probably here, and also the definitions for the tokenizer results and errors. And source location, all of that needs to go over to here. Okay, let's see what is happening. I have a bunch of errors. Let's use undefined start. What? Okay. Do you not include the source age? Apparently you don't. Maybe source age includes value age and then I'm screwed. Yeah. That's a bit unfortunate. Okay, well, let's just shove it all into value age. Whatever. You don't know what the token is. Def struct token. Let's go here. Okay, we already have forward definitions, that's fine. Okay, internal compiler error, that's amazing. Bool. So apparently if the function returns a object and here it tries to return bool, just Microsoft Visual Studio completely explodes. That's great. There's result, and then we say return result. Type is parse result type success. Okay, let's continue. That makes sense. Now that would be a parse result. And here we actually do want to check that result is a failure, right? And result type is parse result type error. Maybe. Actually, at this stage, it probably is not an error yet. Yeah. Okay. So here, I guess it still should be success. Missing, yep. Okay, let's check where we are exploring. I think we are again gonna be at assertion. Okay, yeah. So at this point, it is actually success. And the problem happens in here. So we want to check that main will return now will be null, and then we want to check that dynamic array length of program errors. Yeah. And then we get the first error, so we say parse error is dynamic array get of program errors 0, and we need to figure out what it will be. I guess this is what is gonna happen. So we want nice error messages. So we say check str cmp. Do I want to actually have them as C strings? Not really. Let's make them slices. So slice equal slice literal like this, and error message. Okay. Yeah, so it says that message is actually const char star, which it is at the moment, but that's something I'm planning to fix right now. You're gonna be a slice. That will cause some problems over here, but we can pretty easily fix that. Slice equal, and then say error message, slice literal. Okay, it's actually super annoying that I can assign const char star to the to a slice somehow. I still don't exactly understand why it works in C. So now I have to manually go through and figure out where this is happening. Print message with location. Okay, so I need to, I guess, do the same stuff here. Okay, and then this, and then message, and then slice message. Message, ooh. Message length, message bytes. Okay, that looks good. Where are we actually adding those messages though? Okay, so here I want to do slice literal, I think. Okay, now that should be fine. Okay, let's run this. Still will get that assertion because we have not yet done the main thing. Okay, let's do that. Where's our could not resolve identifier? Where are you hiding? Oh. So this is the entry, and if not entry, what do I want to do? Well, I want to say program push error, and what will that do? I will provide the message. Now, one annoying thing about all of this is that I should, ideally, I want to include the name of the thing that actually is a problem. So like if I say could not resolve identifier, I want to say like S33, but that means I will need to use something like sprintf or something like this to construct new functions, or I can use fixed buffer. Let's try this fixed buffer, but I think it might get annoying pretty soon, but it will get us to the right point for now, for today. Buffer, so error buffer, fixed buffer make. Okay, I don't care what allocator and whatever it uses, because if we are in error state, we really don't care about the memory. It's just gonna explode anyway and exit with bad static code. So program share now. Error buffer, capacity, maybe I should provide capacity is over 496. Okay, and when we say fixed buffer append slice literal error buffer. So we're just kind of using the fixed buffer as the string builder in other languages, if you have encountered that. Okay, slice literal, and now we are able to actually append our name, and I can do dynamic array push. Builder program. So we return 0 now, and whenever we use this function, now we will have to assert, or actually not assert, we will have to check the value, and if the value is 0, we assume that there was an error, and we just bubble it upwards and stop doing anything else. So errors, and value, so we have parse error, it has a location, and it has message. Location might be problematic in this particular instance. Yeah, because we just pass the name to here. We don't really pass the identifier that was with it. So I guess we also will need to parse source location. That's an interesting question. I could push the error here, but what I could also do is I could take care of it at the point where we're actually using this function. And that might be what I will do. So now we have to go through all usages of scope lookup force and add error. So this gathers up overloads. Here it should always be actually correct, I think. Yeah, this is good. This should not ever fail, so we should add actually an assertion that here it is always expected to be true. But there is definitely other places where this is not the case. So we have scope lookup type, and if not value, return 0. Because this is also not the main thing that we are interested in. So now we also have to look for scope lookup type, and in reality that is the actual thing that we need to deal with. Yeah, so this is where we also have the source, and we know the most about the error, because in a just scope lookup force, we know that we are looking up for a value, but here we know that we are looking up a type, and that means that we can give a better message to the user, saying specifically that it's not about identifier. We say could not find type and then type, right? So this is in general much better message than what we would have be able to give there. Okay, here we say parse error. Of course, we need to return 0 and continue bubbling all of that up to all the way there, but we'll probably get crashes now that we put a 0 here, which is fine. Dynamic array push. Message is fixed buffer as slice, error buffer, and then location is token location. That's that build. Error is not the member errors. Location, is it called source? Oh. Source location. No, what is it called? Where are you? No, it is location. I guess it's not called location on a token. Token, where are you? Huh. So I guess I'm not actually adding the location to here. That's interesting. I thought I did. Let's get back to the source file and check what we are doing for push error. So yeah, apparently I'm not really storing locations with tokens, and that is a bit unfortunate. Let's fix that. I will just add a source location to here. Source location. And now inside of the source file, I do need to put it there. Start token, source, that's fine. I just need to copy paste this stuff. It should be okay. Okay. So now we do have location on the token. It means we can report each token afterwards and kind of propagate the location upwards from where it was, which is good. So let's get back to force type and look at what's going to happen when we return 0 from here. Okay. There is also the same problem over here, so I will need to eventually refactor this, but for now, for today, I just want to get the basic structure of what it entails to get errors out of all of this. So we have token force type. Okay, we are doing it in return descriptors. So we would need to say something like descriptor star descriptor is this, and if not descriptor, return 0, I guess. So this is lazy function definition. Okay. It might be necessary to do way bigger refactoring of all of this to propagate the errors correctly, because right now everything is kind of hanging on the assumption that all the things succeed. But that's fine. We can fix that later on. Okay, so we have this stuff, this, and this, and this. Who is calling these things? So this is force lazy function definition, return types. Okay, who is taking care of arguments? You're taking care of arguments. So we have token match argument, and here we would say token match arg. Let's say descriptor star descriptor is this, and descriptor. Realistically, here we don't need to do anything, but where we're using it here, instead of assert arg, we now say if not arg descriptor, then return 0. Type descriptor, yeah. Okay, that is good. What's going on here? We have this token force lazy. We do this return. That's fine. We'll just return bubble up upwards. I guess it's time to just try to run this and see where it blows up. It blows up in the very first function, which is interesting. So I guess I messed up something somewhere else. Let's let our debugger tell us what is going on. Okay. Yeah, that would be very helpful. First of all, if I actually did the right condition. So force type, yeah. Here we need to say if not descriptor, then do this. We do not want to report, obviously, if everything succeeded. But another thing is inside of program init, I did not initialize the array. So let's make that happen. We say errors, we say array parse error. Okay, let's try that again. We proceeded further, but yeah, not really much, because I still messed up this thing where it should be return 0 and then break like this. Okay, again. Okay, so we do not have result at line 71. Let's just run it here. And this is happening inside scope lookup force, which is coming from this thing. Okay, that is actually fine. This is something we can deal with. Scope lookup force here, and I'm asserting result, right? So which is it? Line 71, right? Okay, so it is this one that fails. Okay, well, same just if not result return 0. Just bubble it up. And here, I guess I will also remove that assertion. Okay, we exited with the code 1. That actually is fine, because that would mean that our tests have failed. Where did they fail? They failed over here because I think I changed the actual message I'm using. Error buffer, yeah. So it says could not find type. Where's the test here? Not find type S33. Okay, let's try that again. And now we have the tests passing. Cool. So all of that means that it is now possible to get nice error messages. And one final thing I want to do today is wire it all up to here and start on that. Okay, so that means that program import file now needs to also return this parse result, but that's okay. I thought that might happen. It's a pretty easy change. We just say return here. Okay. And I'm saying if no, here, if parse result, so we are kind of on each step of the imports, we will have to check this. If result type is parse result type success, we do this, otherwise we don't do it. Or actually I can do it like this. So if result is not success, then we just go through all of the errors and deal with them. For U64 is 0. I less than dynamic array length of result errors plus I, and we do this print error. What's it called? Message with location. So print message with location, and message is parse error is get it from the array, and we just output all that. Nothing fancy here. Okay, error message and error location. Okay. If not a buffer, then we need to actually report an error, which we don't do at the moment. So I'll just add to do here. Fix me error. And right now I'll just do it like this. Let's do it right away. Let's not be lazy. So array parse error. Errors is dynamic array make of array parse error. And then we push an error there. Do dynamic array push errors parse error. The only problem is we don't really have a location because this just means that we were not able to load the file. No, that's fine. Dynamic. So message is slice literal enable to open the file. I don't need to provide file name here because the next thing is going to be the file name, right? So I have to say location, and then I say file name is our file path, and then line and can stay 0. That's okay. It's not going to be the most beautiful error message in the world, but it's okay. Like so, and like so. Okay, getting back here. You get I guess I want something like this here as well. And so let's make it, it's gonna return S32. Yes, that's good. But we'll call it print errors, and it will accept array parse errors, and that's actually about it. And it will do this stuff. So like this, we move this here, and now we say return of result errors. Okay, so that's one thing. Now we have the second file import, the same jazz. If we don't have success, we just bail out. And final thing here is if dynamic array length of program errors, then again the same thing. But now instead of result errors, we just send program errors there. Okay. Dynamic array width. Oh yeah. And you can see by the confusing errors C gives how important it is actually to have really nice errors. How do we check that? Well, I guess what I will do is I will take the exit code example and we'll say error unknown type. Get it over here. We don't need, well, actually we can do it like this. Status is S33. Now I will do, let's build, and then we will do build mass fixture slash error unknown type, like so. So ideally, I should see the error message here if everything works out. Apparently, I do not. So what is going on? The assertion is line 777, so let's go there. 777 is here. Well, let's not do that, I guess. We just are okay if the result value is null. No matching overload found. That is a bit unfortunate. So yeah, I will definitely need to expand this because right now what is happening, this function parses just fine, then it tries to find this function and we only piped this one exact case where things fall apart. So I have to do it like this. It doesn't matter what it does. Like this program is actually gonna do weird things if you did try to run it. So if I made it correct, this would do bad things, but because it's an error program, it's actually fine. So let's try it like that. Okay, this is actually what I wanted to know, and we have actually probably the right location. So if I go here, yeah, it does seem to be off by one, but that's something I can check out and fix later. The main part is now we have the basic step errors, we pipe them to the CLI, and all that remaining is just dutifully going through the whole thing of the source and making sure that whenever I had an assertions before, now it's supposed to be checking for the return types, and if something is wrong, either report an error or just bubble it up to the top and continue as it goes. Not a very exciting job, so that's something I will definitely do offline, but it's good that we now have this set up. And with that, thank you very much for watching if you stick around, and hopefully see you next time.